One of the problems faced by parents today is that the high non-technical shrinkage of potential AMR customers that contribute to high losses is a dishonest action taken by some consumers. How to make it easier to AMR officers to analyze and evaluate data at PTPN, which has 34,000 customers with approximately 5 officers staff at present. Assalamualaikum warahmatullahi wabarakatuh. Hello, my name is Yessy Asri. I am the author of this paper with my team, Wina Kuswadani, Evi Yosrita, and Ferdinand Hendrikulu. And this paper title is Automation Clusterization of Historical Power Utilization Customer to detect power losses in an effort to increase the efficiency of electric energy consumption. And this is what my research has been looking at, so let's get started. The current system is currently running for its own technical losses. Errors such as phase RRT are likely to be zero, missing, and also there is a zero voltage due to a broken cable to the meter, or in other words, the shrinkage occurs due to imperfection of the system, so that it can be easily known. Another case with non-technical losses, such as errors in reading the gauge, calibration errors in the measuring instrument, and unauthorized use errors. Customers do not cancel the voltage or current, but theft is done using sophisticated technique or methods. So, for checking and analyze data more difficult than the technical losses. At present, has been applied the method of measuring electrical energy using the AMR, automatic meter reading system, which a system of reading or taking data on the result of electrical energy measurements to consumer locally and remotely, where the reading schedule can be determined as needed. This AMR system can be optimally utilized for account issuance, customer load analysis, calculation of losses or distribution losses, and planning for electricity network development. One of the problems faced by parents is dishonest action taken by some consumers. Non-technical losses are one type of loss that has a major influence on this loss of electrical power, and this is problem because they have to choose which customer to check first. At this time, to detect the shrinkage itself is still checked directly by reading and checking every incoming customer. For that, we need a system can be used to facilitate analysis, evaluation of data as a reference is in detecting non-technical power losses to PLN customers. Research method for automation clusterization of historical the power utilization customer. For input, historical data customer power usage. First, training data, waktu beban puncak, from 18 until 22, and luang waktu beban puncak from 22 until 18 per per 15 minutes for 7 days. Data 103 customer normal or fair use. Second, testing data of 3 customers that are classified as using unnatural, non-technical thinking. And the process, pre-processing data, data training and data testing, then clustering data method using K-mean, and then optimizing the number of cluster with method Davis Borden Index atau TDI, and then output IMR customer power usage patterns and allocation of testing data to the closest cluster. Clustering method. Calculation using the k-mean method to determine group of AMR automatic meter reading customer power usage pattern for business group. The calculation states are as follows. Here, the author taking uh, taking 5 data samples to be used as an example in the calculation process that will be explained the subsequent stage. Customer A, this is customer 1 until 5. This is A, B, C, D. Is explained for A is total waktu bangun puncak day 1. B is total waktu bangun puncak day 1. C is total waktu bangun puncak day 2. And D total luar waktu bangun puncak day 2, etc. until day 7. And then number of cluster K. This study uses several sets of clusters, namely set of 2 clusters to set of 6 clusters. And then random point K centroid, and then calculate the distance between object and centroid, grouping by minimum distance, until the centroid position does not change again. Then the clustering and iteration process. Because the centroid position does not change anymore, the clustering and iteration process end with the final and centroid cluster members as follows. This is member set of 2 final clusters. Customer 1 clusters centroid 1, customer 2 cluster centroid 1, and etc. And then this is centroid set to cluster. Centroid 1, centroid 2 for day 1 until day 7, waktu bangun puncak, and 2 waktu bangun puncak. Optimization DBI method. After doing k-mean calculation and getting group members and the centroid, the following will be done: the validation calculation of the Davis-Baldwin index atau DBI method to see the quality and strength of the cluster, how well an object is placed in a cluster. The following are state optimization with the DBI method is this. Until, based on the calculation result, that the most optimal set of cluster is set cluster 4 because it has the smallest DBI value, that is 0.873 x93. It means that cluster set 4 has the density of its object with the best centroid, and the distance between clusters is also well set. Because the set of cluster 4 has the best performance in grouping the load profile data using the IMR customer in the business class. This is result. Figure 1 explain about optimum cluster set result, cluster optimum. And this is figure 2, customer power usage pattern that do not match the pattern, consumer power usage. Consumers who are said not to fit the pattern or do not enter into any cluster can be seen in the DC, distance centroid, of each customer, which has also determined the maximum DC value for each pattern. If the customer's DC value exceeds the maximum DC value, then it can be said that the customer is not appropriate predetermined pattern. Besides looking at the DC value of each customer, it can also be compared between the waktu beban puncak and luar waktu beban puncak. Value in each cluster and the VBP and LVBP value for each customer. We can see this scatter plot diagram of consumer testing ID2. We can see the point hybrid testing high from maximum DC1 until DC4. This has already passed the highest value of each cluster. And then customer ID safety testing data. This is a sample normal customer power usage pattern. You can see normal customer power usage pattern. It can be seen from the scatter plot diagram that the DC1 to 4 testing data is below the maximum value of DC1 to 4. Conclusion: clustering historical data on the use of AMR customer power usage of business class of PPA and distribution of Jakarta Raya propose to classify and determine pattern of electric power usage and determine operating target based on the number of cluster sets that have been calculated optimally with cluster set 2 until 6. Obtain the most optimal cluster result in set of 4 clusters because it has the smallest dBi value is 0.893, where in the set of 4 clusters, cluster 1 consists of the 12 members, cluster 2 54 members, cluster 3 34 members, and cluster 4 3 members. Second conclusion, customers who are said not to fit the pattern or do not enter into any cluster can be seen in the DC value of each customer, which has also determined the maximum DC value for each pattern. If the customer DC value exceeds the maximum DC value, then it can be said that customer is not appropriate predetermined pattern. Besides looking at the DC value of each customer, it can also be compared between the VBP and LVBP values in each cluster, and the VBP and LVBP values of each customer. The highest value of big WVBP in each cluster has the highest value of 0.453 in cluster 4, while for customer, the weak WBP value is 2.770, which has already passed the highest value of each cluster. So that's all my presentation. Thank you very much for your attention. Acknowledgement, this work has been funded by Institute Teknologi PAN Jakarta, Indonesia, and thank you.